Today I'm here with video number 3 for lesson number 4, structure of atom. In our previous video we have studied about different models of atom, and we have also studied how finally Bohr's atomic model was considered as a standard. Now today we will continue the next part of the chapter, that is distribution of electrons and what is valency. Now you all know that in Bohr's model we have studied that electrons have a location, they revolve around the nucleus in the orbits or shells. But how they are arranged, what is the maximum number, or they are arranged randomly, this we are going to study in this chapter. So the arrangement of electrons in various shells of an atom of an element is known as electronic configuration of the element. Okay, so you know that the arrangement of electrons is said to be electronic configuration. You know there are 4 shells K, L, M and N that are numbered as 1, 2, 3 and 4. Okay. Now distribution of electrons in different energy shell of an atom is controlled by a scheme, that is Bohr and Bury scheme. What this scheme says, that these orbits in an atom, they are represented by K, L, M, N. You know this, and the orbits are arranged in order of increasing energy levels. Means the energy of M shell is more than that of L, which in turn is more than that of K shell. The maximum number of electrons that is present in any of the given shell is given by the formula 2n square, where n is the number of orbit or the shell. So maximum number of electrons in K shell can be, the formula you will be using is 2n square. Here n is equal to 1. So that is 2 into 1 square, that is equal to 2. For L shell, 2n square, here n is equal to 2. 2 into 2 square, that is 8. For n is equal to 3, 2 into 3 square, that is 18. So in K shell it is 2, then it is 8 and then it is 18. This is the maximum capacity for each shell. Okay. Now the filling of electrons in the second shell will only start when the first shell has been filled completely with 2 electrons. The filling of third shell will begin only after the second shell is filled with 8 electrons. Okay. Now let's see some examples. Here it is chlorine. Chlorine has 17 electrons. So how it will be filled? In first it will have 2, then it will have 8, and in the last shell it will have 7 electrons. Same way for helium, it has only 2 electrons, so it has only K shell, and both the electrons will be accommodated in the K shell. For argon, it has 18 electrons, so 2 in the first K shell, 8 in the L, and again 8 in the M shell. In this way the electrons are filled by just using the formula 2n square, where n is equal to the number of shell. Okay. Now these are the atomic structures of first 18 elements. Please go through these structures. You should know how to make them. They are for hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. So please try to learn these atomic structures of first 18 elements. Now this table shows you complete thing. You are having the symbol here, you are having the atomic number, number of protons, neutrons, number of electrons, distribution of electrons and their valency. You can see here the number of protons and number of electrons are always equal for each of the atom. The difference is there in the number of neutrons. Okay. Now our next term is valency. What do you mean by valency? In general, valency is the combining capacity of any element. Okay. Now element which the electrons in the outermost shell, they are known as valence electron, and the number of valence electrons, they determine the valency of the element. The elements having completely filled outermost shell in their atom, they show no chemical activity. Like we have seen for helium, it is having 2 electrons, it has completed its octet. We have seen argon, it was having 8 electrons, means it has completed its octet. So they are chemically inactive. Okay, they don't show any chemical reaction. In other way, you can say that their valency is 0. So the elements with completely filled valence shell are said to have stable electronic configuration. Okay, so one thing is clear, the electron which is present in the outermost shell, that is known as valence electron, and valence electrons tells us about the valency of an element. But you have to keep one thing in mind, when the number of valence electron is close to its octet, okay, then what has to be done? The valency is obtained by subtracting the number of valence electrons from octet. Say for example, the number of valence electron in chlorine was 7. So its valency will be 8 minus 7, that is equal to 1. Okay. Let's see some of the examples. See, for carbon, it has 6 electrons. Okay. It has an atomic number of 6. Atomic number we will consider in our next video. It has 2 electrons will be filled in the first and 4 will be filled in the L shell. So it has a valency of 4. For neon, you can see it is having 8 valence electron. So 8 means it has completed its octet. So its valency will be 0, and they are said to be inert gases. Okay, because non-reactive, because they will not react because its octet is complete. So it is not going to show any chemical reaction. For chlorine, you know, it has 7 electrons in the valence shell. What is valence shell? It is the last shell of the atom where the electrons are placed. It is having 7 electrons. So what will be the valency of chlorine? It will not be 7, but it will be 8 minus 7, that is equal to 1. This you have to keep in mind when the valence electron are greater than 4, that is 5, 6 and 7. Then we have to subtract it from the octet, and then we have to determine the valency of the element. Again, this is the same thing. Number of valence electrons more than 0, less than 4, then the valency is equal to number of valence electron. But if the number of electrons are greater than equal to 4, then its valency is determined by subtracting the number of outermost shell electrons from 8. Okay, so this much for today. Next we will continue in our next video. Thank you.